Thank you all who have been here for the full day. For those who have not yet had an opportunity to visit with us and be a part of a plenary session, just a couple of housekeeping items. So we are using an electronic polling device that allows you to provide questions or comments throughout the entire day in plenary sessions. We'll be collecting all of the questions, even if they're not posed from the podium, as part of the final report for this conference. So you should have received a yellow piece of paper that gave you some instructions of using that Poll Everywhere device, but you're also welcome just to write a question on a piece of paper, and our volunteers throughout this afternoon will collect those pieces of paper. Again, even if the piece of paper with your question isn't posed from the podium, it is being recorded as a formal part of this conference and event. So I have the opportunity of serving as a facilitator for this final plenary session. So a little bit about myself. Again, my name is Susan Metzger. I serve as a Senior Executive Administrator for the Dean of the College of Agriculture and Director of K-State Research and Extension here at Kansas State University. And my background is in water and natural resource policy, so I'm really delighted to be able to be a part of this particular session. Similar format to our previous 3 plenary sessions, we'll have an opportunity to hear from our sponsor of this session, and then we'll hear from one of the authors of the background paper related to climate and natural resource use, who will just provide some framework for our discussion. That'll be followed up by a respondent who had an opportunity to review that paper critically and provide some feedback to share with you today. Then we'll also have 2 individuals that will share just their own perspective of thinking about the topic of climate and natural resource use related to sustainable livestock systems and how we can really have innovation on the ground in practice. And then we'll end with an additional perspective, just something unique or different, either geographically or thought-provoking related to the topic of climate and natural resource use. So without further ado, I look forward to introducing you to Henning Steinfeld. Henning is the head of the Livestock Sector Analysis and Policy Branch at the Food and Agricultural Organizations of the United Nations in Rome, Italy. Steinfeld is an agricultural economist and graduated from the Technical University of Berlin, Germany, which is now Humboldt University. I welcome Henning. Thank you.
Yeah, good afternoon, everyone, and thank you for giving me the chance to present this overview paper that has been done by a number of colleagues, Karen Oppio from FAO, Julian Chada, Kyle Davis, Peter Tomlinson, and Stacy Gunther. We've had a little bit of a difficult process in trying to prepare this document, so it's not entirely ready yet, but it may still serve as a good basis for discussion. I'm not going, my professional life has shown me that if you give numbers or figures, they can get you into trouble. So I have not actually used any figures or graphics or diagrams. I'm just using words. So I'm starting with the large interface of livestock with natural resources and climate. And it comes down to the huge amount of biomass that globally the sector appropriates in terms of grasses, leaves, crop residues, concentrate feed, and other stuff that goes into the stomachs of livestock. But overall, if you look at the human appropriated biomass, it is the majority that goes to livestock. It's more important than crops, it's more important than fisheries and forests together. So the use of land and water and nutrients of the livestock sector is quite substantial. It's the largest land user. It's the largest user of nitrogen, if you look also at feed crops, and it's also a large user of water. But it is difficult to make any generalizations because, as we have already heard this morning, there is a huge diversity when it comes to how animals use resources and what these animals are used for. So we have major species like cattle, buffaloes, sheep and goats, and chicken and pigs, but we also have many minor species that are being used, which are very important in some contexts, camels or donkeys or geese and ducks and rabbits and guinea pigs and what have you. So there is a huge range of systems out there, not only fulfill production functions, but also other purposes, as we have already heard. And because of that, there's also a huge variety of interactions between natural resources and climate and livestock. So any generalization that you make about livestock, anything that you say in one sentence is probably wrong, because it needs a more nuanced consideration and statements around that. What we have, however, in light of the already large use of resources by livestock, is a growing demand. And in Africa alone, the demand for animal products in the next 30 years is about to triple. So the livestock revolution that has kept us awake for the last couple of decades, which started in China and then Latin America, Near East and other places, has now also arrived in Africa, where we have the largest demographic expanse in the next couple of decades, where this will become very acute. We also have, with livestock, a large transfer of what we call virtual transfer of resources. So basically, we have areas like China or Europe, which are protein deficient, and for their livestock, they bring in huge amounts of feed protein, notably in the form of soy. So with livestock and trade in livestock products, and because livestock products are high in natural resource use, you also have virtual natural resource transfers. And then a growing number of countries have actually introduced agriculture into their climate commitments, into their nationally determined commitments when it comes to the Paris Agreement. So they have identified agriculture and livestock as one of the sectors where climate action will take place from a national point of view. We're having very diverse systems, and as we have already heard, these systems play different roles. We have ruminants and grazing, and of course ruminants and grazing also imply the role of methane, because it is largely low value, low protein feed that is being used for grazing in many cases, and of course the role of methane as a short-lived climate pollutant with a permanence in the atmosphere of just about 12 years offers opportunities to look at methane as something that can generate rapid climate action. We also have grazing in natural grasslands, as the US here, and the prairies, the pampas in South America, the steppes in Central Asia. These are natural grasslands which actually thrive best when they are grazed. So in many cases, of course, the wild herbivores have disappeared and have been displaced or replaced by domesticated animals. And they can very much fulfill the function of the wild herbivores. So grass, when it is grazed, is actually more productive, it grows better. Water can be retained, biodiversity can be enhanced. The grazing in natural grasslands is something that provides a range of environmental benefits which are not sufficiently recognized. So we have also pasture as a carbon sink. If it is managed well, again, the capacity for soil carbon to increase is quite large. That is particularly the case where carbon has been lost historically. Historically, we have had about a doubling of grazing areas in the last 200 years, so rapid, massive expansion of grazing that occurred particularly here in the Americas, but also in Australia and Africa. And to try to restore the capacity of these grasslands to use them as carbon sinks is actually quite large. We talk about pastures as the largest terrestrial sink of CO2. But we also have the expansion of grazing into forest, which draws a lot of criticism. So very much we have pasture, but also associated soy production at the frontier of agriculture expansion. And it is here where most damage and most emissions actually occur. So the deforestation that is associated with the expansion of pastures and of crop areas, particularly for feed. And because of this large occupance of land by livestock and the direct and indirect impacts, we also have a large role of extensive systems in biological diversity, interacting with wildlife, sometimes competing with livestock, but also in a complementary way, these two things can be managed. A second system, I just call them smallholders, but these are land-intensive systems that are driven by the need to provide subsistence needs, but also traction and manure, where very often where the livestock system is very well integrated into the overall farm economy, and where there is a closed loop of nutrients and energy which are both being recycled within the system. However, very low productivity in many places and small scales, and therefore limited opportunities to upscale. But there are some high potential areas where the combination of low productivity and high emission intensity gives us some hope that significant reductions in emission intensity can be obtained. And here I'm looking at Africa, Latin America, and South Asia, all areas where productivity is very low and where we have high emission intensity, particularly in rumen production. And then the specific role of pastoralists actually almost entirely dependent on livestock for their survival and for the sale of livestock products. There are about 150 to 180 million people who are predominantly pastoralists, and because of their almost total reliance on livestock, they need to have a special place in our considerations. Then intensive systems, they are present in this country very much, in Europe, but they're also rapidly growing in low and middle income countries. And what intensive systems very often go along with is a geographical separation from the feed base. So you find industrial systems, intensive systems close to markets, close to ports, close to good infrastructure, but very often disconnected from the feed where it is produced. So as a result, you have a nutrient transfer from feed producing areas to livestock growing areas, and with that you have a disruption of nutrient cycles, and which leads to both depletion at the source and pollution in the livestock producing areas. And intensive systems is not only based on technology and making the animal more productive, but a large component is to modify the environment, where you can have a situation where the provision of inputs can be optimized. It cannot be so easily optimized in areas which are not uniform. So the modification of environments, indoor stalls with ventilation, with temperature, with light, all being provided and managed. In these situations, you have obviously much more of a potential to optimize livestock production than in environments which are much more variable. But intensive systems, as I have said, also rely quite heavily on imported feed concentrates, and here the role of soy as a critical component. Soy has come in as a substitute in Europe for meat and bone meal. It has come in as a substitute for fish meal, which has limited supplies, and now countries and companies are looking to replace soy because of the negative connotations with environmental damage. Then we have also in our paper looked at some of these trade-offs and synergies, and it's not easy. I've just picked here some examples. So as you intensify your livestock production system, you relatively emit less carbon dioxide and methane, and relatively more nitrous oxides and other N-related pollutants. So as you intensify, there's a shift. So reduce on one side, you reduce methane, but you're increasing emissions of nitrous oxides, which is an apparent trade-off in a situation like this. When it comes to biodiversity, there's a debate about whether you should actually set aside areas for nature conservation and use the highest potential areas for high intensity production, and by there as a land sparing approach, as opposed to mixing things all over the place and having mosaics which is called the land sharing approach. So two different approaches which provide different environmental benefits and have different environmental costs. And then we have what we call between domain links, so trade-offs. So here we would look at how does the environmental objective relate to other objectives, and the objective of providing food security or an increased supply of animal protein, of course, comes with higher environmental costs because the expansion, the additional resource use that this requires comes at an environmental cost. And when it comes to smallholder systems, yes, we may want to promote efficiency and higher scales, but we also know from development experience that this means that less and less people are actually deriving. We talked about the more than 1 billion. Less and less of these people will actually be in employment, because the tendency, as I don't know how much we have in the US, but 1% of the population may be engaged in primary farming, and that figure is very similar in Europe. In Africa, it is still much higher. So basically, when it comes to innovation, the theme of this conference, we look at it as 4 basic strategies that can be used, already discussed in the morning. Actually, most of what I have has already been presented in the morning. So the concept of emission intensities, which expresses the amount of greenhouse gases that are emitted per unit of product. And there, of course, we've seen all over the world actually a decrease in emission intensity, mainly driven not by climate concerns, but just by the paramount objective of increasing productivity. So productivity and emission intensities are inversely correlated, and that is actually a nice synergy that we have between the two. Then to try to integrate livestock much better into the circular economy by trying to recycle nutrients and energy much better than is currently the case. So trying to use crop residues, agro-industrial byproducts, everything that can be used as feed. For example, the use of drags in biofuel production in the US provides an example of how livestock can take advantage of these changes in terms of what becomes available as a resource, but also to use animal waste and to recover energy through biogas and nutrients from animal waste and bring it back to productive use as a fertilizer. Offsets, I think the livestock community needs to argue that it provides important environmental benefits, not only in terms of carbon sequestration in pastures, as we have discussed, but also in terms of biodiversity and water retention, water cycles, water quality are all dependent on a good management of the land, and here grazing systems can show and should be compensated for providing these environmental benefits. And then I think we need to also take into account that there is a fair amount of path dependency, I think that's what they call it in economics, in livestock, that we continue to think of this as a conventional model that will be around forever. Now, particularly with soy, there is a strong tendency to replace soy with alternative forms of protein, algae protein, microbial protein. Insects are being experimented with, but it's basically to alleviate the pressure on land use expansion that drives many countries and companies to look for alternatives to soy as a protein feed. And then there are also a range of innovations that relate to replacing meat, milk, and eggs with plant-based substitutes, and massive amounts of investments are taking place. And we see consumer preferences shifting towards these products. I know that some of you will doubt whether this will be just a hype, a short-term hype, or a more long-term tendency. But basically to know that the livestock industry and the traditional livestock products, at least some of them are being challenged by the emergence of substitutes or alternatives. So what does this mean for any policy? I think first of all, it has been said before, but recognize diversity of livestock systems. They all have their place, the different systems, and they all fulfill their functions, but we also must look at them with their distinct features and how susceptible they are to different policies. What we've seen, however, particularly in low productivity situations, that the productivity for improvement and for alleviating the environmental stress of these systems is quite significant across all systems. We've made a comparison of how the performance, the environmental performance of the best 25% of a farming population in any given location compares to the average. And that is a huge gap. In terms of beef only, it goes from 90 kilograms of CO2 equivalent per kilogram of meat to more than 400. So we have a huge range within which beef is produced. And just bringing that down to the average, or bringing the average down to the performance of the best 25%, would give you an enormous amount of greenhouse gas emissions, but also environmental impacts that can be reduced. I think the discussion for us as the global agenda for, well, this is really serious now, has to take place in the context of healthy diets. I think what we need to realize is there's a huge interface between private gains and global public goods. That is also the same for AMR, but the individual action has a massive impact, or could have a large impact, on everyone. So there's a mismatch here, and that's why we have externalities, both positive and negative externalities, and there is a need for these externalities to be reflected in prices. So we need a mix of regulations and incentives. We need a central role of innovation at all levels, and as the climate change discussion intensifies, I have no doubt that the livestock industry will come more into focus when it comes to climate change policies, which is also an opportunity, because there are some quick climate gains that we're able to show. Thank you. Sorry, I'm running over.
No, it's good. Thank you. Thank you, Henning. And I was remiss to skip right over a very important part of this plenary session, and that is our plenary session sponsor, which is DSM. I'd like to invite Dr. Irmgard Immig to come up and share a video and a little bit about her company. Would you like me to start it now?
No, first you have that you show the logo, maybe? Okay, sure. Good afternoon to everyone. Still energized for the last sessions here? So it's my first time here in Kansas at the university, so I was not studying here. I even don't know anyone here. I'm not coming from an agricultural background, but I have one species that is very close to my heart, and that are dairy cows. And I feel sometimes really very sad when I hear about all these negative talks about dairy cows and how they are polluting the environment, and sometimes you have the feeling they are really the biggest burden in the world. But what we forget very often is that they produce really something very important for humanity. And I'm really astonished that I met here now someone from the Alma Mater in Berlin, from the Humboldt University, because I was there as well in the early 90s. So it's very nice to meet you here, Henning. Coming to DSM, I don't know if you know the company. DSM, basically, the abbreviation means Dutch State Mines, which means we are a company that is global, but with headquarters based in the Netherlands. And we come from quite some history, because more than 100 years ago, DSM was basically a coal mining company. But over the last years, this has changed tremendously, and we are now really in life science and material science. And we have one segment that is a nutrition cluster, which deals with micronutrient, vitamins, fine chemical nutrition in humans, also, of course, in animals, and we have special segments also in the personal care environment. And why are we so interested in being here and also being a sponsor is exactly looking back to what Henning Steinfeld has said, all these things he has mentioned in his talk, that is what we are interested also in. Thank you for your attention.
Thank you, Dr.
And for a nice continuation of the program here.
Thank you, Dr. Well, thank you, Dr. Immig, and thank you to DSM for sponsoring this particular session. I would also like to now invite Ian McConnell to come up and share some remarks and provide a response to the paper on the climate and natural resource use. Ian is a World Wildlife Fund's global expert on livestock and a globally recognized expert in animal production systems. A fifth-generation beef producer, Ian gained a Bachelor in Science and Animal Studies at the University of Queensland and then spent a year at Colorado State University supporting meat science and genetics research. Ian.
Thank you. And firstly, I want to thank Henning and his team for this paper and the chance to respond to it. It's an interesting role that we play as WWF in this space. I coordinate a team that works in 15 countries around the world where we actually work on the ground in livestock production, looking at this very interface. How do we look after the environment while producing food, fibre and energy off those systems? So this report actually captures a number of things that I find really challenging about what we do in the livestock industry in this topic. This morning when we spoke about food and nutrition security, livelihoods and economic growth, we spoke about the obvious positive benefits of the livestock system. This afternoon, as we talk about animal welfare and the environment, we start to look more at the trade-offs. And it does present a slight danger that it may come across negative when looked at on a topic on its own, not through the lens shared of those economic, social benefits that it provides that we discussed this morning. But through that framing, it's also important to recognise, as Henning said, that the livestock industry is a significant challenge as well as a solution. For many years, WWF has produced a thing called the Living Planet Index. It is a scorecard of the health of our natural systems. It counts our species, the health of those populations around the world. And it's been declining since the industrial age. Our natural systems are at threat, and they're represented very clearly in that set of data produced annually. That impact is being caused by a whole range of systems, but as this report clearly articulates, the food system is central and one of the major drivers of that decline in the health of our natural systems, and livestock a very key part of that food system. It is the conversion of natural ecosystems and the unsustainable use of natural systems that are seeing our natural systems degrade. But it's also on those natural systems, especially in the extensive systems, where livestock plays an important role. This duopoly, this hypocrisy of livestock being good and bad, is the challenge that we see in the way that we perceive meat production in the environment and climate discussions. It's very easy to say one sentence, but as Henning made clear, if you say one sentence about global meat production, it's probably going to be wrong in most places. The nuance is critical. This is the first report that actually starts to articulate the benefits that we are measuring now. We do have now 3 peer-reviewed cases of carbon sequestration net positive under livestock production. I'm excited the number is as high as 3, but it's also a major threat that we only have 3 when we look at the large scale of our grasslands and savannas that are being utilised under livestock. In fact, we know that the carbon storage on grasslands globally is degrading. 80% of grasslands globally were degraded in the last 5 years. There's only 20% of our natural grasslands left in the United States. So if livestock is also a solution to those landscapes, the data is clear right now, it's also the greatest threat. So this Living Planet Index, we need to stop the decline. We say plateau the loss, but plateaus go up, so I'll say valley the loss. Over time, we'll begin to look at how we reverse that decline and start improving our natural systems. But right now, the efforts must be to stop the decline. We need to look at how we preserve natural systems The idea of share or sparing land, it's a little bit of both. In some systems, we're going to have to spare land, systems that can't coexist with food production. But there are systems where we can do it well, grasslands and savannas being one. I'm also struck both by my experience in this report around how we talk around natural resources, climate and meat because of the vast difference in the way we produce meat around the world. In grasslands and savannas, as we said, it can be positive, but most of our meat globally now is produced in intensive systems. These intensive systems, for the most part, will always come at net environmental loss. That is offset by huge social, nutritional gains, economic gains, but on this topic, it will always be a net loss. We've seen vast efficiency gains in those spaces mean we produce more from those inputs, but we do need to think, as we head towards a 1.5 degree future, as we head towards a crash of our natural systems, at what point do we actually need net gain, both in our food, energy, social systems? And what role does the meat sector, livestock sector, play in helping address that positivity that we're going to need moving forward? There is also a challenge in the way this discussion is managed by those outside of the sector. This is a hot topic for many people. Diets are an emotional issue, and Mario, who's speaking in a couple of minutes, will know that better than anyone. But we do need to continue to operate within the truth. The discussions will happen, good, bad, or indifferent. That's social media. What we do need to do is take ownership of the challenges and the solutions we need to provide and move forward in them. Some of the statistics in the report around biomass appropriation, land footprints and water footprints start to in a more nuanced way categorise what we mean by the footprint of meat production and dairy production. Sorry, Brian, he didn't look up when I only said meat. One of the challenges we do have is that we do have a large land footprint, but that footprint isn't a clearing of land in all cases, a removal of nature, a degradation of landscapes. We need to find better ways of measuring what we call our footprints and what our indicators of sustainability are. The reason we need to do that, both as industries, as sectors, as governments and in policy, is because we need people to have choice. If livestock can be good and bad, we need to provide both producers and consumers with choice to produce or consume the good or the bad. It's only when we provide that choice that we start to bring back in the economics of production that will reinforce the change towards more sustainable practices. I'm also reminded of an analogy that, I came up with, so I'm not reminded of it, but this idea of an urgent tortoise. If I'm a tortoise, I know I'm a tortoise. And if I need to get somewhere in a short period of time, I'm going to set off now. We deal in the livestock sector with what is one of the least educated sectors globally. Even in developed countries, it is the least educated sector. We also deal with very conservative people. They're at the whims of nature, and hence it breeds a conservative nature. Change can be scary. So if we're going to see urgent change, and Henning, you stated the quick gains around climate that are needed, we need to start now. We don't need it solved now, but we need to start taking that pathway in a more direct way. We need to take ownership as sectors to see that change occurring now. If we don't take ownership now, the amount of time, the lag in that journey will create a real challenge for us moving forward. Because while we talk a lot about the impact of livestock on the natural systems and climate, what hasn't been articulated well is the threat to this sector itself by the declining natural resources and a changing climate. No other sector is a greater threat to those systems than the livestock sector. We are primary producers. So if we don't address those needs and take ownership ourselves of those changes that are needed, we will be the sector most at threat. So that this obvious hypocrisy, and this obvious hypocrisy of livestock production, that you ask anyone that runs a beef cow, they love beef cows, yet we send them to slaughter. We also live in nature. We love nature, Yet our sector, our industry, is currently the biggest threat to natural systems, while also being potentially one of the best solutions. We need to take ownership. We need to look at that bell curve. As Henning said, move the average towards the top 25%. If we do that, not only do we create all the benefits that we spoke about this morning, food and nutritional security, economic and livelihoods, but we also see a more resilient natural resource base and climate that will provide humanity a safe future moving forward. I look forward to your questions. Thank you very much.
Thank you, Ian. And now I'll invite Tom Jones, our first Innovation in Action presenter. And Tom is the manager and owner of High Plains Feedyard in Montezuma, Kansas. And the company feeds 10,000 head of cattle annually. Montezuma, for those that are just visiting Kansas for this week, is a bit too far for a bus trip. But if you ever find yourself back here, I certainly encourage you to visit Tom's operation at High Plains Feedyard. It really is impressive in the work that he's doing in sustainability. Tom.
Thank you, Susan. I appreciate the kind introduction and the kind words. And we upped our production just the other day to about 100,000.
Oh my goodness, I missed a zero.
That's the only time I've ever been able to do that to you. I'm sorry, it's a free shot. I am Tom Jones, and my operation is about 275 miles southwest of here. We are an intensive cattle operation. I guess that's a bad word to some people, I guess, but I know when I get there at about 9 o'clock in the morning, sometimes it's getting pretty intense. So that's the usual thing. We're going to talk about sustainable beef, water conservation, and I guess I thought last night we'd talk about regenerative agriculture, and we'd also talk about carbon. And Henning and Ian have raised the bar on the feed yards at this point right now. I agree with you with most of your points, and so now it's up to us to address these things. It's on our mind. It's on our mind of a lot of progressive feed yards out in industry today. I'll tell you a little bit about our company. And we're a licensed 50,000 head one-time capacity feed yard. We're 85% customer cattle, 85 to 90%. That means that as far as myself and my partners go, today we own about 1,200 head of cattle, and the rest of the 38,000 head of cattle are 280 owners across the U.S. and Canada. Our mission, you can read that, we're improve sustainability and stewardship of the natural and financial resources of our customers and ourselves through targeted research. We've moved into genetics, feed efficiency, pharmaceutical use, ruminant nutrition, soil health, and some other things as well. Water conservation is a big thing that we're leading into right now. We've been working on this for 3 or 4 years. We're just starting to feel like we've made some progress on it. Limited irrigation cropping systems, and that's if we have we've got one of our producers that we've been working with that they've just turned their farm into a water conservation area. So we're moving into that where parts of that farm will have to lower some of its water use from 30 to 50% on some of its ground. Also, when we're talking about limited irrigation water, we're talking about can we make some other feed source out here? Can we use some other starch source out here for our cattle for energy? And right now, the feed yard industry across the U.S. is basically using corn. And you know how much water it takes to grow a bushel of corn. When we have available to us out here now another crop called milo sorghum that we can grow. The problem with milo, when we look at it, we're running about, as far as energy, it runs about 12 or 13% lower than corn does. So we're going to have to make up that energy in our rations with something like a tallow, a fat, or some other energy source. The other thing about it is that our production cost when we flake that stuff is going to be it will probably be another 5 or 6% higher for our energy costs to do that. The other thing that we run into too, and as Ian talked about, we still run into profitability on it. So how do we get a farmer to grow us milo sorghum? And when we offer it at a price at him at 15% lower than what we have to buy his corn from, and he'll save money on his production costs of water, but he doesn't feel he's making enough money by doing that. So we have to explore other nutrient combinations as well. We'll talk about our facility. 3 years ago, my partners and I decided to get into research. We built our research area. This is our barn. This is the inside portion of our research center. Our research center is made up of a seating capacity, heated and air conditioned for 200 people, where we can sit down and talk about some of the topics that we've done research on. And we have a processing area in the back, and we also have an office for my geneticist I have on staff. I also have a PhD DVM on staff. This PhD DVM works for a company called VRCS. It's a veterinary group in the United States. They manage 1.25 million cattle on a daily basis in 63 feed yards across the country. I do not have access to any of that data from any individual yard, but I have access to that data as a pool. So that's one of the key things that starts driving our research. You can see here what in our processing area, when we talk about feed efficiency on cattle, the first one we start looking at is about 20 years ago, we got into the business of measuring cattle. And there's 3 data points that we collect on our cattle that we started with back then, and we're still using them today. And our pool of data has gone up to over 100 million cattle. But what we'll do is we'll take a weight on these animals, a hip height, and then we'll measure the distance between the hook and pin bones. All that data is plugged into an equation, and it's algorithmic, of course, and then that'll give us optimum in weights of these animals. So when we get a load of cattle into our feed yard, the average range from the biggest to the smallest animal in that deal is greater than 200 pounds usually. It runs between 200 and 300. Actually, a 200-pound difference between the biggest and smallest animal on a 3-load or 120, 40-head pen would be very narrow. So we have to. That's how we try to feed these cattle to their optimum endpoint. So all these cattle have a different phenotype. So we collect those different phenotypes into 3 different groups, and we'll have 3 different marketing windows, and they'll typically be 2 weeks apart. And so we know exactly, for the most part, I'll say exactly is a big word for a feed yard and a cowboy talking, but for us it's close. We'll know what the endpoint is on these cattle, and we'll take them right up to that endpoint and then decide if we want to harvest them at that point. Our current research right now is we have grow safe nodes out there. I'm sure you're familiar with them. We have enough nodes to do 400 cattle at a time, and we're studying residual feed intake, and we're doing this on bulls, heifers, and progeny. If you boil that down, what we're trying to do is we're trying to find the cattle that eat the least and gain the most, which is counter to the industry that we feed cattle today. Typically, I make my money by selling feed to these customers. So the more feed I sell, the better off I'm going to be, correct? Well, but then this industry, we've decided that that's not sustainable, and we're seeing it. We have to become more efficient in what we're doing. So we're taking seed stock operators. We brought them into our group, and another person we work with and has an office at our facility is ABS. They're number 6 seed stock operator in the U.S., and they're worldwide as far as dairies go as well. And they're pretty strong down in South America and Brazil with their new era crop, when we're working with some of those Bos Indicus type cattle and trying to kind of work into a little bit better carcass quality on those down there. And so we're also working on this as far as feed efficiency, and we know that it's only 40% heritable. So once we start going around, when we're checking these cattle, we'll do these intake studies on bulls, heifers, and their progeny, and we'll repeat that 2 more times after that before we really made we've improved a herd, by quite a bit. Another study we're doing, pharmaceuticals on high-risk cattle. We've been talking about antimicrobial resistance all day long. We've been 2-3 years into that, and it's we found that if we go back, and our first place we're going to start is going back to the cow-calf man and making sure these vaccination programs are right first, and that's the best place for us to start. We're also looking at animal behavior, and You're going to ask why. So when we have our grow safe nodes, we can watch what the consumption is on these cattle. And from my perspective, I would have never guessed that I can have an animal out there with similar weight, if he'll be an 800-pound animal. Within this group, the one animal, the lowest consumption will be 18 pounds, and the highest consumption within that group, and he'll be the same weight, will be 50 pounds heavier. And so we're studying the consumption and the habits of these cattle, and we're finding things that we really didn't know. We haven't introduced any different management practices yet, because we're still studying this. We're only 2 years into this thing. Another thing we're looking at on this consumption behavior, what leads to why do some cattle get sick and why do some cattle not get sick. We talked about communicating with ranchers about their vaccination programs. We talked about our animal sorting and management to target our optimal finish weight. And we're utilizing our genetic research with our seed stock operators to move in these cattle into higher quality grades. You've seen we had a drought 5 years ago in the U.S., and we improved our, we've got 1 minute left, we improved our quality grades from 70% up to where we can run 100% choice now. Greenhouse gas emissions, these are calculated greenhouse gas emissions going along with Henning's idea of what are we going to do? Can we manage these cattle differently out on pasture? And yes, we can. Here are our future research areas, and I want to move down to soil health and carbon sequestration before we get shut down here. This is the company we work with out here, our grazers, Circle Land and Cattle, and these are the water conservation area people that we're working with. Our priority goals, or their priority goals, are to conserve water, of course, and then beef cattle pasture background programs, rotation of in-soil baled ensilage and things like that we can walk off or haul off the pasture and then go into a background program. So we're looking at soil health as our next thing, 5 main principles. Henning went through most of that, and we can work through this thing and actually make a big difference. I'll stop at this after I show this last slide. There's more. When we talk about carbon sequestration and being able to do it out in the feed yard in our country out there, it's very possible. We're 2 years into this project with Jiggett Land and Cattle Company, and I want to show you this up here. And you guys may think this is not unusual at all, but this is the soil that this was grown. This is not their farm. This is a neighbor's farm. You can see that there is no organic matter in that at all. It's basically beach sand, and that's what this is, basically beach sand up here as well. But through a crop rotation system, cover crops, conservation agriculture, we've turned this into, look at the organic matter in there, and we actually have a live earthworm in the thing. It's remarkable. And I hope we have some more questions about carbon sequestration, and because I think that our goal is to become carbon neutral, and I think it's doable in Kansas.
Thank you, Tom. Our next innovation in action comes from Walter Oyhantcabal, who will join us on the stage here. Walter is the Director of Sustainability and Climate Change at the Climate Change Unit in the Ministry of Agriculture in Uruguay. And since 2000, he has been involved in the UNFCCC negotiation process on issues related to agriculture. Walter.
Thank you very much. Good afternoon, everybody. Thank you very much for this opportunity to exchange with you in this Global Agenda meeting. I have to say that it is a double pleasure to be here in Kansas. One is because in my childhood, the cowboys were my heroes, and the prairies of Kansas and other similar states were in my mind and in my fantasy. And now in the adult age, I'm still related to similar landscapes and similar activities. In that time, the cows were not bad, but now we are trying to demonstrate that they can continue being good. So I'm going to share some of the things we are doing in Uruguay. Well, Uruguay is a country with economy strongly based on the livestock sector, which represents a huge part of our economy, of our exports, and also of some of our environmental footprint. We still have half of the country covered with natural grasslands, with very rich biodiversity, which we must try to preserve because of the benefits it can provide to the human society. Our beef sector is mostly grass-fed on these natural grasslands. We have, since the last 15 years, mandatory traceability of all cattle with electronic and visual ear tags. We don't use growth promoters due to the requirements of our markets, and we do not change land use to increase productivity. It means we don't have deforestation at all. In relation to GHG emissions and the opportunities for mitigation, well, the livestock sector is absolutely dominant in Uruguay in the global national inventory of GHGs. As you can see, almost 3/4 of all our emissions come from livestock. So we have a lot of non-CO2 emissions in our inventory and very low CO2 emissions, contrary to what is the general rule in the planet. But those emissions are of biological nature, and they are linked to producing food and fibers, so it's more difficult to control them because we don't have alternative sources of food as we have alternative sources of energy. So since 2010, the current administration in the ministry established the proposal to achieve 3 win-wins at the same time. It means not only to produce more and more quality, but also to reduce the environmental footprint and to mitigate and to adapt to climate change. So we think that what we need is to change the paradigm that has guided livestock production in Uruguay, in particular cattle, and introduce a new one in search of a higher social and environmental value added. This concept of environmental value added is in the core of the policies that are implemented in Uruguay. So we speak in terms of co-benefits. What co-benefits and how do we obtain these co-benefits on the ground at farm level? And this is something that we are implementing using a methodology that is called co-innovation. It means farmers with technicians. So the co-benefits we are looking for are more productivity, more economic, social, and welfare benefits, but also preserve or restore biodiversity, maintain or increase soil fertility, and make the most of the ecosystem services. And co-innovation is a method to work with farmers in which farmers and advisors and institutions at local level work together. So it's a kind of social learning process to plan, to develop a farm plan for the medium term, and that looks at the farm as a system, as a whole system. Actual action on the ground is focused on the 4 regions that you can see in the map. We have a plan to support change in some 3,000 farms that cover some 1 million hectares. But at the same time, we have a subset of farms, which we call monitoring farms, where we are monitoring the more relevant variables related to the social, the economic, and the environmental performance of the system. This is something very difficult to do when you work with 3,000 farmers, where you can get only a limited set of indicators, but we have a representative sample of farms and also control plots in order to try to measure and attribute in the most robust possible way the impacts of the technological change. One of the innovations that we are proposing, compared to the way in which the grasslands have been managed in the last 200 or 300 years, is to move from a system in which, as you can see in the baseline, the dominant characteristic was overgrazing, with all the consequences of overgrazing, which is low photosynthesis, low leaf area index, low primary productivity, then low forage supply to the animals, low digestibility, which is very important in relation, for example, to methane emissions, and low overall efficiency of the system. So the idea is to move from this situation to this alternative situation. And this is already, not for the future, it's already happening. So the alternative is to work with more grass. This is the synthesis of the message we are giving to the farmers in order to increase the net primary productivity, the forage supply for animals, improve the digestibility, productivity, and the efficiency of the herd. And this means moving from this point, which was the dominant point of overgrazing with low forage supply to animals, to this optimum place, to the green place. This is the optimum. Then if you continue moving, you start decreasing the productivity. So systems have to move in this direction in order to improve the productivity. And for that, they have to learn to measure the forage availability and allocate the animals according to the requirements, the category, and the availability of forage in the different paddocks. For that, they have to measure. To measure, we have developed a rule that establishes a relation between the height of the pasture and the availability of dry matter. But also, other innovations that are needed are the changes in managing body condition, introduce temporary and or early weaning, flushing of the cows before mating, increase the weaning rate, and decrease the slaughter age. All these parameters increase the efficiency of the system and also have benefits in terms of environmental performance. Carbon sequestration is one of them, or at least when we suppress the overgrazing, we can expect that we stop losing carbon from the soils. Then, if we do something like this, in the overgrazing situation, we have a very limited height of the forage, but also very limited root system, which the farmers does not see. And when we move to working with more grass situation, then also the underground biomass is much bigger, and it releases more carbon as raw matter to manufacture organic matter. But we not only need carbon to build organic carbon, but it's also key to have the nitrogen box bigger. If we don't have nitrogen, then most of the carbon is respirated as CO2. And many of the failures trying to increase soil organic carbon are due to not understanding the tight relation between carbon and nitrogen. So we need to manage both. And the way to introduce nitrogen in the system is through biological fixation by legumes. And the benefits of this adequate spatial and temporal grazing management are more than the ones that I already showed you. We not only can restore soil organic carbon and organic matter, but we increase biodiversity. When the system is overgrazed or has very low grazing pressure, the biodiversity is smaller. The optimum biodiversity is in an adequate medium grazing pressure. So we are moving to this point. And also, when we increase soil organic carbon, we increase water storage capacity, and this increases the resilience of the system. And we reduce the need for external inputs because we are recycling the nutrients and we are increasing the fertility of soil. On this basis, Uruguay, in the first NDC to the Paris Agreement, presented a singular commitment in terms of emissions intensity. we can stabilize our emissions and produce more, but we still don't know how to produce more with less gross emissions. So the idea is that we can reduce, and this is the target for 2025 and 2030 in our NDC, and we can reduce 1/3 the emissions intensity of methane and CO2. So produce more and more clean in terms of GHGs per unit of product. And this is a target that we have presented, and we are installing the monitoring system in order to transparently demonstrate if we can achieve this or not. We hope we are going to achieve it, but it has to be demonstrated ex post, not only as an ex-ante estimation. And the important of that these changes that we are promoting with farmers are not based on subsidies, are based on this triple win I told you, in which the farmer increases the net income of the farm. So this is the main incentive for him to maintain the new technology once he has adopted it. And the increase is really significant. This red line is the progression of the net income, in which you see that the cost increases but not that much, and the income, the gross income increases a lot because of the increase in productivity. In few years, 2, 3, 4 years, farmers are increasing the productivity in kilograms per hectare in the order of 50%, which is really huge. In summary, and I think that in my last minute, yes, I am in my last minute. Well, in summary, we need to use ruminants for what they are good for. This is very important, and we are seeing many times that the truth is forgotten. We have 30% of the planet covered with grasslands that are not edible. We already know this well, but this is a big value of ruminants. They can transform cellulose into protein of high quality. And in lands that are not able to produce other crops or bioenergy crops. Third point, it's very important to increase the recycling of residues of byproducts of cropping and other activities, contributing to a circular economy. Without the complementarity between plant production and animal production, these synergies and this complementarity and this circularity is lost. So we need both. It's a false contraposition, animals or plants. They have their own role in the trophic chain. We have to recognize also the multiple values of nature contribution to people via animal husbandry. For example, meat, but also ecosystem services that have to be identified and qualified and quantified as best as possible. And with all this, we not only produce meat, but we produce meat with an environmental value added. This means that we can intensify grazing systems without losing the advantages of the extensive systems, and also minimize emissions intensity and enhance sinks. So what is the key for innovation? Innovation requires to redesign the system. Every system produces the results it produces. If you want different results, we need to redesign the system. This is very obvious, but normally it's not done at ground level. And this redesign had to be done on socio and ecological or agroecological principles, and on the basis of a process of capacity development, because these technologies for grassland management, that is a very complex system, are knowledge intensive. Not input intensive, but knowledge intensive. So this needs a special program to develop capacities at farm level to take the right decisions. Well, that's all, and thank you very much.
Thank you, Walter. And our final presentation of this plenary session, in the additional perspective, comes from Mario Herrero. And Mario is the Chief Research Scientist and Office of the Chief Executive Science Leader at CSIRO, Agriculture and Food, and is an Honorary Professor of Agriculture and Food Systems at the University of Queensland, Australia. Mario was awarded his postgraduate degrees from the University of Edinburgh. Mario.
Put the computer here. Well, thank you, everybody. It is a pleasure to be here. I really would like to thank the organizers. I would like to thank Henning especially for also facilitating me being here. I've been asked to provide an additional perspective on this session, and probably what will happen is that I'll reinforce some of the things that Henning said in its great paper. But I'll also try to provide some additional things, some additional thoughts. Let me see how this works. Okay, I'd like to start by saying, look, we're finally reaching a global convergence on the need for more sustainable food systems. And here, as an example, I put the latest 3 reports, the climate change and land report from the IPCC, the Eat Lancet report, and the report from the WRI on creating a sustainable food future. Look, the climate change and land report from an IPCC perspective has a number of really important firsts. First, it is, remember, it was fully ratified by all the countries via a voting process, and it was unanimously accepted. And this is the first time that the IPCC recognizes fully 2 things. One, the need to focus on land as a key aspect of adaptation and mitigation in the food systems. And secondly, that a food systems approach is really needed for picking up all the trade-offs and synergies that you can have in mitigation and adaptation. And why is this important? Because for the first time, they actually recognized fully at governmental level that both the supply and the demand side will need to play a role in mitigation. There has been a lot of science recently around this, but I mean, from a government's perspective, this is a milestone. And this is important because you've heard many times in the last decade, that sustainable diets, that what we eat will actually impact the environment and diets. And there has been an enormous amount of research in the last decade on the need to produce and consume foods with lower carbon footprints. And, well, the livestock sector has featured in many of these examples as as foods with very high intensities. What you've heard the most in recent times is the Eat Lancet report. And the Eat Lancet report basically just tried to give the message that we need to rebalance the plate into trying to make the vegetables the star of the plate rather than the piece of meat or all the discretionary foods that we can actually also have sometimes. So this is very important because, look, it's not really just trying to say, well, we need to eat less meat or less red meat. It really depends actually where we are. So this rebalancing in many countries will actually necessitate increases in consumption of animal source foods, while in other places we will need to actually diminish the consumption. This is the graph, and one of the graphs of the report that is very widely used. Let me see which is the pointer. Yeah. And what we see here, well, there's a very large variation in the consumption of most of the animal products at the continental level. So in many of these places, there is a need to maintain the increases in consumption, but in other places we would need really some reductions in consumption. And also, what is very important to notice is that vegetables, fruits, whole grains, nuts, we're basically very deficient in all of these. We're not consuming enough of these. So it's really a balancing act that will take a different shape depending on where we are. But I want to say something really important in relation to the scenarios that were tested. Primarily because a lot of the people focus on the reductions in the consumption of animal source foods. And look, this slide may appear daunting to many, but I'm going to try to explain it in 1 minute, okay? So what I want you to focus on is these were the planetary boundaries used in the Eat Lancet report, and then these were a series of scenarios. This is the current conditions of those planetary boundaries. So we are already exceeding the greenhouse gas emissions, phosphorus, and biodiversity loss. We're still okay for cropland use, water, and nitrogen application. As Henning said, it is wise not to go into the numbers at this point, so I won't mention any numbers. But what I want to also say is that what we tried in the Eat Lancet report was to examine a business as usual scenario where we had the current waste patterns and also the current diet. And then we had 3 things to play with. A dietary shift, an increase in the productivity of cereals and livestock. This is basically what we call sustainable intensification, and a very significant effort in waste reduction, which will be very much in line with what we consider on principles of circular economy and so on. The first important message here is that if we just do the dietary shift, we only deal with the greenhouse gas emissions because we end up using less land. But actually, that's not enough to really deal with all the planetary boundaries because look what happens. We'll need more fertilizer, more land, and a range of other things. It's really until we really maintain and really increase our efforts to sustainably intensify the system, reduce emissions intensities, etc., together with reductions in waste and the dietary shifts, that we manage to get there in terms of all these. The point that we still need a considerable effort in sustainable intensification is very rarely made when people talk about the Eat Lancet report. And it's something very important because, as Henning said, this is actually one of the things that will lead to reduced emissions intensities, which is actually something very important. So at the end of the day, imagine that the food system is like a pressure cooker, but we have a range of valves. So we're trying to remove pressure from the heat side, but from the top valve also, and so on, trying to make everything match. And we need all the strategies, is the most important thing. Then the other point that I want to talk about is that in the Eat Lancet report, we examined what was feasible now. And what is feasible now is not what will be feasible in 10, 20 years' time. There is a considerable effort in trying to find disruptive technologies, things that could actually really move us completely to new production systems, get us gains that we have not seen in many opportunities. And this is actually happening immediately. Look, 10 years ago when Elke Steffes wrote that paper on the climate benefits of a changing diet, yeah, a lot of people said, oh yeah, but come on, that will never happen. At the same time, in 2010, there was a review paper on artificial meat. And again, nobody took it too seriously. And look, now it's really in full-fledged, in really going strongly. Several of us who worked in Africa in a decade when the mobile phone, we all started with our Nokia 3210s and moved across, and look, even the pastoralists moved to the apples and all the others. There's been a monumental amount of innovation happening very, very quickly. Just to give you an example, we recently did an inventory of about 150 potentially disruptive technologies. Now, the message here is that there are plenty of these that are really applied to the livestock sector. So there could be a lot of new things coming up that would be almost ready to be adopted, or that have an enormous potential and could be very broadly adopted in many different systems. For example, we've mentioned the circular economy, and from our rankings with a range of stakeholders, we found that yes, this is one of the key things. Plant substitutes could be also very, very important, but also look, also all these things on new feeds, using algae, using high oil grasses and others. These are things that could potentially really change the way the livestock systems look in the future. Just in relation to the circular economy, I think that we really need to take it really seriously. And in many cases, look, livestock are probably the circular system. If you look at many of the smallholder systems, there's already a very significant use of residues and a range of other byproducts. This is, for example, some work from Hannah van Santen that we did with them. If you look at this circle, this is basically an internal boundary, and this is 7 grams of protein per capita. This is, if you could produce livestock only from low opportunity cost lands, you would produce 7 grams of protein per capita. If a person needs 50 grams, well, look, it's not an insignificant amount. Now, if you could actually use all the restaurant residue, all the other food waste that occurs, if we could produce safe swills and things like that, this could increase to 23 grams of per capita. That's almost 50%. Yeah, I'm almost there. This is almost 50% of the protein consumption. Of course, this is a theoretical amount, and there will be many competing claims for those resources. But this just shows, look, that there is enormous potential to actually think of increasing the level of circularity in the systems, and this will require regulations and so on. As another example here, a civil engineer from the University of Queensland contacted me and said, hey, you know what I'm doing? I'm producing microbial protein from sewage systems. I said, okay, look, that sounds fantastic. Yeah, look, we've known that we can do this since the 70s, but it's only now that the energy prices are really low that new possibilities are actually starting to occur. And they actually use several in-reactor mechanisms to produce microbial protein to replace soybeans. We did a calculation of what would happen if we could replace a significant amount of the soybean, and you could get up to a reduction of around 7% of greenhouse gases from livestock. That's just one technology, one potential future technology. Now imagine if we really embraced this and really had a big arsenal of technologies to really engage in things like this. I think that this space is very promising. Yeah, I have 2 slides and then I'll finish. Yeah, look, I want to say one thing. It will be expensive at the beginning. There is no doubt, because the early adopters usually bear the cost. But at the end of the day, the quicker that we engage in this, the cheaper it will become. The costs will be a lot higher in the future. So we really need to do this to get the necessary economies of scale, to get patents and IP transferred to places where we can produce these things cheaply. And this is the hard disk. Would you pay $3,000 for 10 megabytes? This is a photograph from 1984. So this is a very good example of this. And then, just to finalize, this is about accelerating food systems innovation. And this will require a dialogue that fora like this, like GASL, could actually help really with the transitions that we need. And this is all, look, it's about building trust, it's about really thinking broadly, transforming the mindsets, ensuring and having a very honest discussion about social license, market incentives, policies and regulations, and as Henning said, ensuring that we know something about indirect effects, and patient finance, which will be really needed to achieve these gains. Thank you.
Thank you, Mario. As Mario's making his way to his seat, I will just mention that with the speaker's permission, all of these presentations will be available after the event. In addition, all of these are being recorded, and so if there was something in particular you wanted to go back and pay attention to at a later date, we will share the YouTube link so that you have the opportunity to do so. We're limited on time because I want to make sure that our plenary sessions have the opportunity to start as close to time as possible. So I do believe we have time for at least one question. And this question can be generally to anybody on the panel. The use of biomass by livestock was addressed, but the alternative use of biomass was not. If fed to livestock and converted into a high-quality human food source, what is the alternative to make biomass a part of the food system? I invite anybody to address that.
Well, I think for the very large part of the biomass amount, there is no other alternative. For most cellulosic biomass, going through an animal is the most efficient way to put it within the food system. The bit, though, that comes a bit challenging is the crops we grow for livestock. We've heard, and the work done by FAO and Motet around finding that around 14 to 15% of biomass is only in competition with humans. The bit that's confusing in that statement is the opportunity cost. The land that's used to grow that smaller proportion of biomass could also be used to produce human food. So that opportunity cost of that part of the biomass discussion hasn't been quite addressed. There's no doubt that livestock are less efficient than we are if we're able to eat the same thing. But there is no other suitable technology yet to use grasses in the food system.
Yeah,
Mario, then Henning.
Can I add to that?
Yeah.
Hello, am I? Yeah, okay. Yeah. Look, one thing that we know for sure is that some of the pathways for using that biomass are really not very sound alternatives. For example, it was widely demonstrated in the Climate Change and Land report that using that biomass for the production of bioenergy would actually have a significant, would act in detriment to food security because of the space used, because of the land used that could be otherwise used for growing crops or other forms of food production.
Yeah, just from my side, I think that's probably true that for the bulk of biomass that is appropriated by livestock, there's not a ready alternative in terms of opportunity cost. But it is also true that, look at low tillage systems, for example. All the crop residues, you're competing with certain of these biomass in some ways. I know in India, cardboard is produced out of crop residues. So that crop residues is no longer available as a feed and has actually found a productive use. And you can say the same thing for pastures that are being degraded. Maybe that biomass should be left there and should be, that territory should be allowed to go back to forest or go to a different form of land use rather than keeping it in a state of degradation. So on balance, it's correct. There is not a ready alternative use for most of this material, but in some certain places there certainly is. And I think, again, the main thing I think that everyone says here, you need to really look at every option and exploit every option, because it's not that we have a single message here. We're having a multitude of messages, each of which represent a valid option and each of which should be actually pursued.
Thank you, Henning. So I do apologize that we want to make sure that we go to our next session on time. And as we've learned from all of these sessions today, the point of each of these sessions is not to exhaust the dialogue, but to create the dialogue. So hopefully you learned and heard something today that you want to continue discussing throughout the week, and especially through dinner and tomorrow. So I do invite you to go to the plenary sessions. You'll find those on page 5 and 6 in your program booklet. And you also have the map to help direct you to those rooms. And a couple other quick announcements. If you have registered to join us for dinner, that's just right across the street this evening at the Alumni Center. It's walking distance. And if you're looking ahead to something that you might want to do on Thursday morning, if you were intrigued today about what the global agenda for sustainable livestock is, you want to learn more about it and consider potentially being a member or even a sponsor or donor in the future, I invite you to join us for breakfast on Thursday morning, and you'll find that in your program booklet as well. Thank you.